Okay, so we'll continue with the second part of momentum as a vector. Now, based on the fact that we have momentum as the direct proportion of the mass and the velocity, we can say that the magnitude of a momentum is directly proportional to the mass and directly proportional to the magnitude of the velocity. We are not discussing the direction here, again, for the simple fact that the direction of momentum and the direction of the velocity are the same. Being in a direct proportion means that whatever you are doing to one side, you are doing to the other. So if you are increasing the mass by a factor, then by the same factor, the momentum, the magnitude of the momentum will be increased. In the same logic, if you are decreasing it, then the same rate, the same factor that you are decreasing it will be affected. When we are saying increasing, that means that we are multiplying, and when we are saying decreasing means that we are dividing. So this is what we are doing when we are having an increase of mass by 5 and a decrease of velocity by 2, then we are multiplying by 5 and we are dividing by 2, which will result into a magnitude of the momentum of an increase in this case, because it is greater than 1, of 2.5, and the same logic as when we have it here. So now we'll see a question when we have the example 5. When we have an object that has a mass of 2.50 kilograms, that has a kinetic energy of 3.82 times 10 to the power of 2 joules. What is the magnitude of momentum for this object? Now, magnitude of the momentum can be expressed like what you see it here, or can just simply be as P, in the same way as what we are doing for the magnitude of any vector. You can say that the magnitude of vector A, can express it like this with those two lines, or you can simply say what is magnitude of A. Both ways are correct, they're acceptable. The first one here is more scientifically right, but both are fine. Anyway, so now, in order to find the magnitude of momentum, we would need mass and the magnitude of the velocity. Based on the fact that we know what is the kinetic energy of the object, we will be able, and the mass, we will be able to figure out what is the velocity of this object. So from Physics 20, we know that kinetic energy is a 1/2 mass velocity squared. You have two ways to do this. Either to find what is the velocity using literal equations. So you can find that the velocity is 2 kinetic energy, 2 times kinetic energy over mass, and then square root it. And then take this relationship and place it into momentum. So momentum will be mass times the square root of 2 times kinetic energy over mass. And if you are very into math, you can say that either put the mass inside or take the mass out. So you can go mass times square root of 2 times kinetic energy over root mass is the same thing. And then root mass and mass can be simplified, because what mass is actually a root mass times a root mass times a root of 2 kinetic energy over root mass. and then root mass and the root mass is canceled out. So the magnitude of the momentum as a formula now will be the square root of 2 times kinetic energy times the mass of the object. And then you substitute what is given. So 2 times kinetic energy was given as 3.82 times 10 to the power of 2, I think, times mass was given as 2.50 kilograms. If you are worried about the units, I will do the units here on the sides. So joules, what joules are actually are kilograms meter squared per second squared. So when you are multiplying kilograms meter squared per second squared and multiplying it with kilograms, then kilograms and should be canceled out. Oh, this is the square root of it. Yeah, it's the square root of it. So the square root of it, kilograms, and then you will have that is going away, roots and roots is canceled out, and then you will have just meters per seconds and kilograms. So this will be the units of momentum. Now, if you are having difficulty of approaching this literally, which is figuring out an equation that gives you the answer for every number that is possible, then you can do it in a different way. So this is if this is method 1, you can do it in a different way, and there is nothing, and when I say nothing, literally nothing wrong with doing it, as you finding the velocity based on the fact that kinetic energy is 1/2 mass v squared, and then from here you go, kinetic energy as given was 3.82 times 10 to the power of 2 is equal to 1/2 mass was 2.50 times velocity squared. So now you multiply by 2 both sides and divide by 2.5 or 2.50. And this will be v squared. So v squared will be 2 times 3.82 times 10 to the power of 2 over 2.50. So you will have 305.6. And then the magnitude of the velocity will be the square root of 305.6, which is 17.4814 and so meters per second. And when you are calculating momentum, magnitude of the momentum will be 2.50 times 17.4814, whatever is that number, because the rounding will happen at the very end, times 2.50 will be equals to 43.7 kilograms meters per second.